Okay, good morning again, everyone. This is the last slide that we saw during our in-person class. So we're going to continue with the rest of this lesson. So just as a reminder, what we have gone through was the preliminary stages of, well, a wiring or installation project. Okay. Now, the last one was billing, and that's my favorite part. For the money that you get, you can buy more tools that you can do more jobs with. And as I said, you can buy your favorite car that you always wanted. Or if you play your cards right when doing the jobs and bidding on the jobs and billing the jobs, you can even buy your that island somewhere in the Caribbean that you always dreamt of. All right. All right. So that's the second part here, site work. And site work, when it comes to infrastructure installations, it would, well, first you would establish the raceways, all right? And we're going to talk about some of the raceway installations, but for the most part, the first real thing that you're going to see when things begin to shape up is going to be the rough in. So the raceway you can set up with raceways such as cable trays, conduits when needed, and there's another thing here that if you look at the picture here, you're going to see something like that here. I just put a picture of that. And that is a little device with the, well, in this case, it's a shape of inverted J, but that looks like a J shape. So that's, and it's a hook. So you know what? These are called J hooks, right? So J hooks also can be part of the raceway, all right? All right. So rough in as a first stage of wiring here. After planning the cable distribution, the rough-in stage begins. What is a rough-in? All cables are pulled to the home run. Sorry, all cables are pulled from the home run location to their destinations. So you just run the wires, and sometimes it takes an hour, sometimes it takes 2 hours, sometimes it takes 2 weeks, and sometimes it takes 2 months, depending on the size of the project. So it's a structured way of installing the structured systems. All right. So, excuse me again, all cables are pulled from the home run, and the home run is usually some communications room or telecommunication closet or otherwise known as LAN room as well. Okay. So it will be some kind of a central point where all the cables are running to, and they're going to be terminated and connected in a certain way. So all cables are pulled from the home run location to their destinations, and the destinations could be anywhere all over the building or facility. Could be the desktop, could be walls, could be ceiling spots, could be floor spots, wherever they need to go. Right? All right, so the cables, the next thing here, the cables are coiled in bundles at both ends, but not terminated. Right? So what I just put here on the right side here, well, these are a bunch of cables, and these are on the reels. So some of the cables are going to be mounted on the reels, and some on something that's called the cable racks or cable pulling racks. And those can be purchased for a certain amount of money, or you can just makeshift some of them. It's just, you know, to make a pulling rack, all you need is some sort of a snug enough or stiff enough pipe that you can mount on some sort of couple stands, and so you could put you can thread that pipe through the reel here, and as you pull the cable, this thing unwinds. The cable unwinds from the reel, and you can just go and do the pulling job. Usually, and I would say 99.9% or maybe 100% of the time, what you're going to see is going to have somebody unreeling or unwinding the cables from the reels, just so the pulling force can be, well, equalized. Because if there is somebody that on the other end somewhere and tries to pull those off the wheels, you could create some sort of a interesting mess. Right? Some of the cables might be unwinding more equal than others. All right, if I can say that. So there will be one person here standing and just controlling the wires coming off the reels and feeding that to the person who is going to do that, to feed the wires onto the structure on the other end. And then on the other end of that, there could be a third person that is going to pretty much pull the main bundle of the wires, right? So in this case here, it would be a 3-people job. You could solve this thing with 2 people. It's going to take a little bit more time because with 2 people, you're going to have to undo the wires from the wheels and pull enough slack to lay that on the floor. And then this person goes over there to feed the wires here, and that person goes over here to pull the wires up down to here, right? Now, can you do this thing with one person? Sure you can. You just undo the wires from the spools here, walk all the way down there just to lay the wires on the floor, and then you would just go and get a ladder and maybe pull them halfway and get enough slack here, and then pull the rest of them here. So here's the thing: if you have 2 people doing all the wire pulling jobs would be done with 2 people minimum. Here's the simple calculation. If it takes you 10 hours to do the wire pulling while you have 2 people on site, if you eliminate one person, the job time does not double. It's not going to take you 20 hours. It's going to take you at least 30 hours to do that. Just the way it works. And if you put that thing to an experiment, you will know exactly what I mean. So, rough in stage, you pull the wires to the destination where they are supposed to be, and you just coil them up. Why do we do that? Well, so we could establish some sort of a structured way of organizing your work. If you do repetitive action such as this, you can be more efficient in completing your job because you are going to have certain tools, you're going to repeat certain type of procedure, and things to go faster this way, faster, more efficient. And so safety first always. You can hear that everybody repeating safety first, but also the efficiency and the speed of doing the job should also come in play. So a good balance of safety versus, well, of course safety first, but if you just want to be completely safe because something can happen to you, just please don't leave home, right? Well, let's not get philosophical here. All right, so that's the roughing in, and it's a common terminology on on the site. My apologies. I think I'm clearing my throat here a little bit. The morning thing. So what else did I write here? Okay, no. Make sure that all cables are clearly identified at both ends. Okay, remember when during the labs we are putting a great weight on labeling the cables. When we did the labs with the patch panel, we asked you to label the cables at both ends, even if those wires were 12-inch long. All right, so it doesn't matter. It was the lab. So the purpose of lab is to practice for the real situations. So get into the habit of labeling the cables at both ends, so you don't get yourself into a quite interesting mess when it comes to further tasks that you need to do to complete the job, right? So when you have 500, 600 wires, and none of them are labeled, or some of them are mislabeled, or some of them are just labeled on one side, then you can find out the hard way, and you will never ever do, do that again. Or you can just listen to what we're saying here and not make the mistake, right? So make sure that all cables are clearly identified at both ends. All runs are securely mounted in the ceiling space or otherwise raceways, depending on the situation. And the work is done according to the local building and electrical code. One, excuse me, sorry. One basic rule here is when you are running free air wires, over the years, some procedures have been established in order to do the job properly. Right? What do you mean properly? Well, so you don't get the job rejected by the inspector. What happens? One of the well, there are a few rules that you need to apply as far as the type of cable. But let's say we have the correct cables. As far as cable suspension, all cables should be suspended independently in the ceiling space. What do you mean? What do I mean by independent suspension? There could be some other structures in the ceiling, and you're going to see some of the, when you pop the tiles, you're going to see all kinds of world living on its own, right? In the ceiling there, all kinds of different devices and mounting rods and whatnot. Some years ago, it was a popular thing just to do the job quicker. People would mount those wires, the cables, well, low voltage cables, for example, such as these, like data cables, or should I say extra low voltage, right? They would mount those cables or fasten them to the to the to the rods that are holding the suspended ceiling frame. That was a pretty popular procedure to do, to follow. And nobody would pay attention to that. Some people would, some people wouldn't, but things would be let go. Now, right now, we are not supposed to do that, right? All the cables are supposed to have their own independent suspension structure. The way I was explained was that it's, believe it or not, it is for the fire safety and regulations, right? The reason for that is that in case of a fire, the fire crews would go in, and sometimes they would have to, well, bring some structures down to get to the whatever they have to get to, right? And they use those little, or not so little, hooks on the sticks, whatever those are called, and they just grab things, and sometimes they have to bring things down. So if there is some sort of cabling mounted to those ceiling rods, it would create extra hazard for the fire crews while they're on site. Right? So that would be one of the reasons. Right? So all the cables are supposed to be independently suspended using your own raceways. Right? Yes, it takes a little tiny bit longer to install those wires, but that's what we're supposed to do. So that goes with this slide. Let's just see what's next around the corner. Sound, site work, roughing, tools, and pathways and raceways. Cable installation begins with establishing the pathways. All right. So that's what we just talked about. Free air runs. All right. Main runs should be kept in bundles, and suspended independently of any ceiling structures. Okay, so these are the notes you can go over when you're studying for the test, and when you're getting some knowledge to do the real stuff, right, which is more important than the test. All right, so as much as possible, establish straight runs. So pulling multiple cables can be done efficiently. J-hooks mounted on the walls or suspended from the ceiling on threaded rods are the most common in this scenario. So let's just take a look at this one here. As much as possible, establish straight runs, so pulling multiple cables can be done efficiently. I'm just going to go back to the slide before here. See, that's what I mean. Establish straight runs. Sometimes it's easier than other times because you are going to see a bunch of things mounted, bunch of devices, air ducts, some control devices, HVAC devices, uh, all kinds of things could be there. So sometimes it's not as easy to establish a straight line, but nevertheless, try to establish a straight line and then mount the hooks. Um, so, what do you mean by the wire being pulling for the efficiency of the pulls? Well, if you have a straight line, let's say you have a bunch of those J hooks mounted in a straight line from here all the way to there, right? All you have to do is establish a pull string, and that's like a twine string. It's a rope or a twine string. You go from the beginning to the end of the pull, and that's where you're going to be pulling. You tie those wires onto that string, and if it's a straight line, you should be able to pull those wires quite comfortably. If you have bands, you're going to have to pull the slack at every band, so it's going to take you longer. So you're going to have to pull the wires from here to here, pull the slack, lay it on the floor, and then move on and just pull there. So that's for the efficiency of the jobs. Plus, things are much more neat, and here is a big word: things are serviceable. Serviceability means the easiness of the troubleshooting or servicing later on when you have to come back and do some alterations or otherwise work with the job that was already established. All right, so how do you establish a straight line? The easiest way would be to just pop your head in the ceiling, right, and do a visual check. Where can you establish straight lines? Then what you could do is get your ladder and maybe pop a bunch of different ceiling tiles. And if things are in the early stages of construction on the site of construction, then the ceiling tiles won't even be there. Just maybe open frame would be there. All right, so that's much easier. You're going to try to pull a string, just that twine string, from one place to another, and you're going to. It takes two people sometimes. It's easier to establish just by suspending the string, just making that string snug to see if you can establish a straight line. If you can't do that, then great. You just fasten the string to some ceiling structure on one side and on the other side, and you have a snug string established, showing you the line, the straight line. Then what you do, you get a drill and whatever you need to do, and you just keep mounting the J hooks along that string. Then what you do, you just go and just put that string onto the J hooks. There you go. And then Bob is your uncle, or the name of your uncle is Bob. You just establish the wire pulling structure by tying the bundle of the wires on one end. You go on the other end. Somebody feeds that from here. Somebody pulls that from there, and you are pulling one straight line. Okay? So here, free advice. So there's a reason why I say things like that here. So right now here, if you just, a couple minutes ago, this was just a little tiny sentence that if you don't slow down, you're going to drive right by it. All right. So here, but now you have some kind of a substance to tie this thing to. Right? If you go and do your job, then you're going to have even more substance in the shape of, in form of experience. Right. So as much as possible, establish straight runs. So pulling multiple cables can be done efficiently. Main runs should be kept in the bundles and suspended. So here again, if you don't slow down and if you don't look, you're going to drive right by it. Main runs should be kept in bundles. Again, it all comes down to planning your job. You're going to look at your drawings and you're going to see, all right, so here's an office here, here's an office there, here's something else here, here's going to be a printer. How many wires do we need from that spot to this spot, and get as many as possible that you can do in one pull? Well, sometimes you're going to pull just 3 wires because there's going to be one jack here, and then another. So just 3 wires, and you're just going to pull main bundle, and just wherever they're supposed to go, you're going to branch them off and rough them into where they're supposed to go. But sometimes it takes about 12 or 15 wires. Well, in my time when I was doing those jobs, running 12 wires in one bundle, it was not something that was uncommon. It was a quite popular thing to do. If you could do 12 wires, yes, of course, it needs a little tiny bit more pulling force on your part. But when you do the job right, you're not going to stress those wires, and the job is going to be done more efficiently. So if you do the more wires, it's a simple calculation. The more wires you can pull in one shot, then you're going to save just that much time if you were going to pull each wire at a time. Right? So when you do the jobs, when you have a job to do in your house basement, 1 or 2 wires, then you can take all the time in the world, and nobody's going to look over your shoulder and tell you to go faster or slower. But when you're doing this thing for a living, then things like that are important, right? As far as speed, efficiency, and of course everything should be done safe. All right, what was the last one here? J hooks mounted on the wall or suspended from the ceiling on threaded rods. We're going to talk about what threaded rods are. So the J hooks are the most common in this scenario. Some of the most common. Some of the wire trays are also there, or some conduits, but most of the time in commercial situations, these would be the most common ones, the J hooks. Excuse me. All right, raceways. As the alternative to free air, so this would be a free air run. Right? The wires are not in pipes, they are not in conduits, they are not in some sort of enclosed structure. Right? So that's what free air means. Whoa, 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 whoa. Okay, let's go back here. As the alternative to free air method, closed raceways or cable trays are used. So sometimes you're going to have to establish the raceway or use already existing ones. All right? All the raceways should be installed before the cables are run. Well, it just makes more sense. If you do the repetitive work, you use the same tools. You don't have to change the tools or rearm yourself with other tools and procedures, and so you do the repetitive work, install things that it should be. So, well, establish the raceways. In order to establish raceways, you're going to have to know where the wires are, where the wires should be going. So there's a little bit of planning, and just using your drawings takes place there, right? So all the raceways should be installed before the cables are run. Hint: position the J hooks no further than 4 feet apart to avoid cable sagging, and sometimes, or quite often, this line is included in the contract that the J hooks are supposed to be no further than 4 feet apart. If you put those J hooks too far apart, those cables are going to sag. All right, you're going to have those kind of like wavy looks. And so who cares, right? So you close the ceiling tiles, you're not going to have to watch that. But the problem is that when you have the sagging, the cables are stressed on right on in this point. And when the cables are stressed, they have physical pressure on them. Then they're being altered. It's just like stepping on the cables or just like pinching them when they are stressed against the edges of the whatever this framing would be. Right? So generally 4 feet apart gives you a nice compromise between, because you could do every 6 inches, no problem. uh, but but you're not going to do that, because it's going to take you forever, and it's going to take you how much more money to thrown away, right? Wasted. So 4 feet to get some sort of nicely established straight lines, and so to avoid the physical stress on the cables that are resting on the J hooks. All right. All right. Next, just gonna Can I do this? Yes. All right. Remember I was talking to you about threaded rods. It's a common thing. So look at this here. This is what a threaded rod looks like. When you have time, and I was just talking to some of us that they would go to Home Depots and Ronas or Home Hardwares and whatever local stores and just take a look and see what's out there, what tools are available, what kind of structures, and that some of that it can catch your attention, and you can do some further research. Or what do you use this for? What do you use that for? It's a very efficient way of learning about what's available on the market. And sometimes there are some new tools and some new things, but sometimes are going to be things that are being used for a long time. Like, for example, the threaded rods. Take a look at some of the threaded rods. These are wonderful things. These are, I just say, this is like the Lego for grown-ups, because then you do the real stuff. With the Lego for kids, you are playing, but the playing kind of makes sense because children are learning by playing. But now here is where you are going to apply all that learning by playing with Lego. But this here is just, as I said, Lego for grown-ups. You can use those threaded rods in many different applications. For example, right now, here is some sort of a tray suspended from the ceiling. Now, on one side, you can see a strut channel that can be used. On the other side, there is some support from the bottom. And look, here is a threaded rod. You can cut those two lengths. When you go to some of the hardware stores, take a look at some of the threaded rods. They come in different lengths, and they come in different diameters, different gauges. Oh, look here. There is another way of using a threaded rod. Here's a strut channel on both ends. And here's a threaded rod suspending that from the ceiling. And this holds, looks like a air duct or something like that. Now, on threaded rods, you can mount wire trays as well, or you can mount J-hooks. Right? So let's just see what I wrote here. A threaded rod, a relatively long rod that is threaded on both ends. So sometimes you're going to see pre-cut rods, and you're going to have a bit of thread here and a bit of thread on the other end. And also, there's another thing here. The thread might extend along the complete length of the rod. Usually that's the case. So basically, you can cut that to length and just file off, taper off the ending, so you could put some bolts and nuts there, right? Or nuts. So a common thing is to just before you cut it, you just thread the nut to it, just about this far. You cut that, and then you just undo the nut from here. And as you're undoing the nut, it is going to smooth out some of the thread, so you don't have to do so much filing and making sure that you can start the threading on this cut end. All right, next slide. Here's another way. So we're looking at the strut channels here that are mounted on the threaded rods. So I'm just showing you some of the tools that are available for mounting things, because when you go to the side, you don't want to just look at, oh my God, what can we do? How can we figure this thing out? No, you just kind of just take a look. Oh, right, no problem. From here to here, we can mount the tray on the threaded rods. We can use those threaded rods, no problem. Do that. Then you have to figure out how many of what to buy, instead of how can we do this and what is available on market, so what can we buy. So I'm just giving you that information, that kind of knowledge here in this. That's the point of this whole presentation today. All right, so let's take a look at the strut channel. All right. Strut channel is a standardized formed structural system. Oh, wow. Used in the construction and electrical industries for light structural support, often for supporting wiring, plumbing, or mechanical components such as air conditioning or ventilation systems. That's what this thing looks like. And then again, it's being sold in some lengths of maybe 6 feet, 10 feet, or whatnot. And you can cut this to length. And then again, you can use that as just like the Lego for grown-ups. All right. Now, when you download this presentation, here's the thing: says click to watch. So you click to watch. Because what can you do? You can cut this to length. So okay, so you have a certain length of a strat channel, right? Well, okay. What else can you do with this thing? How do you mount the threaded rod to it? Well, look at this thing here, spring nut mount. You can fasten one side of the strut channel to whatever structure, maybe to a ceiling or wall or whatnot. Next time you're in our lab, take a look around. See if you can find those. I bet you have walked by those 100 times and not noticed that they exist. Now, as soon as you walk in the door, I bet most of us are going to notice where these are being installed and the regular installation for the structure of whatever needed to be installed in our lab. All right. So spring nut. Here's a nut with a spring. Combine these two, you get a spring nut, just like the Apple Pen song. Yeah, okay. All right. So here's a thread, and here's a nut that you can insert in that channel in a way that it stays there. And then you have the spring pushing it against that structure so it kind of stays in one place. And now you can use that threaded rod and basically twist that thing right in here. And look at that. You got a supporting structure. All you have to know is what you're doing with that, right? You have to plan what you're actually going to do. But here is a way of doing it. Spring nuts. All right. Now, here's a bigger picture. Those struts, usually they come here in the, well, kind of a half-slotted channel such as this. Sometimes they come with the punched channel. So here's a bigger picture because sometimes I use this presentation in person, so I can throw this thing on a bigger projector so people at the back can also see. All right. So these are the different kind of shapes that the strut channels, and these are just some of them. Right? Some of the most common. All right, I might ask you some of that on the open book test. Why not? Right now, one thing I'm going to have to point to you, because it would be just unfair to you if I just say, okay, you can cut this to length. What do we cut this thing with? Oh, get a hacksaw. Sure, you can get a hacksaw, but you are going to spit your lungs out before you cut a couple of those because you're going to use that hacksaw a lot in that. You're going to get tired. Your arm is going to fall off. Not really, but you know what I mean. So you're going to use some mechanical tools to cut those strut channels. Here's the thing to know about that. These strut channels are made out of galvanized steel, or otherwise galvanized metal, but steel. And here's the thing to know about galvanized steel. If you heat it up, because look, whatever the blade that is being used, and you can find different, you can use grinder blades to cut those, or you can just use some blades manufactured for cutting steel. And most of the time, you're probably going to end up using a chop saw as opposed to miter saw. There are differences between chop saw and miter saw. I'll let you figure that one out. All right. I just want you to know that there are differences between chop saw and miter saw. Now, let's see this guy's using a chop saw. Look what's happening here. there is heat generated. Sparks are flying. That means this piece of metal is at that spot is being heated to the point that actually sparks are flying out of there. Take a look at this link when you download this thing, or you can just research this thing on your own about something that's called metal fume fever. When you cut, especially when you cut or heat up to the point that things are heating up, galvanized metal, there are certain fumes that are being released, and it's like all those silent killers of the night. Silent killers that you're not going to know anything, but it's going to affect you for later on. So, if you're doing this thing a lot, please take some precautions, use well ventilated area, and if not, you may have to use some respirator masks. All right, just so you know, okay, cutting galvanized metal to the point that you're going to heat that up, and it's not that hard to heat it up with the chop saw because there's some speed involved and friction. Yes, you can have some heat generated there. It releases fumes. Breathing those fumes, no good. Right? I mean, like, okay, guys, really, breathing those fumes, no good. Please remember that. All right, let's talk about J hooks. We're putting this whole thing together right now. J hooks can be metal or plastic. A very, very common thing. If you go to any electrical supply store, ask them to show you some of the J hooks. Well, they're gonna bring you some. Some of the there's like aluminum or steel, or there could be plastic. Well, depending on the price, depending on the size, depending on what's available on the market, you can use either or. Right? So this is what the plastic ones look like right here, and they come with different type of mounts. So you can mount them in like those would be ceiling mounted, but you can order or get the J hooks, plastic ones that are wall mounted, just like that. There could be cascadable. You can mount them one after the other or underneath the other, right? They are also rated on how many wires one J hook can handle, and you're going to see some specs on those, or how many Cat 6A wires can you fit in this J hook, or you're going to see the specifications on the cable. How many of those can you fit in, or what kind of J hook would you need to fit on to fit so many of those wires? And for most of the time, you're going to see some of the 1-inch J hooks, 2-inch, 3-inch, 4-inch. These are some of the most common sizes. And look, they could be mounted on threaded rods. Those threaded rods can be mounted to the ceiling, or they could be mounted on some steel structures using specific kind of mounts here. And whenever you can buy those in some of the electrical supply stores, you're going to see that you can buy maybe some threaded rods, and maybe you're going to see that they will have different solutions of mounting those threaded rods either onto the ceiling or some other structures, or you can mount those J hooks straight to the wall, or you can mount those J hooks straight to the ceiling, depending on what the situation is. You're going to use You have a lot of options there, right? And sometimes you're going to divert to some of your favorite options for whatever reason. Okay. Now, J hooks. That's how you mount those J hooks on threaded rods, and you can mount them on either side. You can use the space efficiently. Those J hooks can be just mounted by themselves, or you can mount them. You can double them, right? Or you can just stack them up and down, left and right. All right. Try to keep 6 inches. This one says 6 minimum clearance above the ceiling. See, this is the drop ceiling, and this is the true ceiling here. Try to maintain about minimum 6 inches clearance above the true ceiling. Right? Okay. How do we mount things? We need to mount things in the ceiling sometimes. So here are some of the options: ceiling or walls. But if we're dealing with the threaded rods, most of the time you're going to mount them vertically. So here's a threaded rods mounting example. And look, this one is actually called threaded rod hanger. We have, well, we have a nut structure here on the outside. So you can use a nut driver. We have the main part of it, the main body of it, threaded sort of like a bolt that goes into the ceiling structure. And these would be the concrete to fuse the concrete ceiling, right? So first you're going to have to pre-drill a hole of a certain size, and when you buy those, there will be specifications of what drill to use to pre-drill the holes. And you're going to have to use some heavy-duty hammer drills to do that. If you don't know what hammer drill is, please research that, or just go to some of the stores and ask and look at things, touch those things. But if you get yourself hired to do this job, you're going to find out what a hammer drill is soon enough, sooner than you think. Right? Now, here's a little tiny bit of a challenge sometimes that you're going to come across. Nothing is easy, right? So, yeah, okay, if I just showed you this, yeah, well, you just drill a hole and put this thing in. And there are certain ways of putting those in. Well, and there are lots of videos on how to use a specific piece of equipment. I can't show you them all, right? Well, look, here's just a concrete ceiling. So you drill the hole, screw that thing in, and mount the threaded rod in it. Okay, again, the name of your uncle is Bob, right? Well, sometimes you're going to have a perforated ceiling. So you're going to have concrete ceiling covered by steel, the layer of steel. Can you use hammer on steel? Yes, you can. Nobody's going to tell you not to. It's a free country. However, if you do that, you're going to destroy the drill bit. And some of those drill bits are expensive. So first, you're going to have to drill through the steel with a bigger drill, just so you can use a hammer drill on the concrete. And yes, this could be, well, one of those bigger jobs that you're going to have to do, and just sometimes it just has to be done. Right? All right. Here's another example of how we can mount things into the ceiling structure, for example. Right? Here's something that's called a drop-in anchor. I'm showing you these because these are the common things, and the more you know about existence of this, the better off you will be, right? The more employable you will be when you see this kind of stuff. When you know this kind of stuff. All right. Here's something that's called a drop-in anchor. Right? Again, for mounting threaded rods. You can mount threaded rods to those drop-in anchors. I'm just going to go back a couple of slides here. Sometimes you're just going to use those drop-in anchors or threaded rod hangers. So you could put a bolt, so you could just hang those J-hooks straight onto the ceiling. Yes, you can do that too. Here's a drop-in anchor. Now, the procedure is slightly complicated, but not that much. What you need for this, you need a hammer drill to drill a certain size of a hole to fit a specific drop-in anchor. And they do come in different gauges, different sizes. And then you're going to have to drive that in. So the cheapest way would be just get a regular, sometimes even cordless hammer drill those holes. And then you're going to watch this video here. Please watch this video when you download this presentation. It shows a pretty interesting way of mounting those. When you put those in, they're just going to fall out. So you have to expand those tail ends of that drop-in anchors so they stay. And then you can you can drive a bolt or you can drive a threaded rod in it. How you do that? Well, you drill a hole, put that in, and there is a specific insert that you are going to insert that in here, and you just hit it with a hammer a couple times so those tail ends here, those flaps expand so that thing stays in there. Now, excuse me, if it's 1, 2, or 5 of those, you can do it that way. If you're doing a lot of them, let's say there's a job site that you're going to have to install maybe 300 of those, and those numbers go up quick. You're going to have to get some heavy duty drill so those holes can be drilled with less effort. You can buy those drills or you can rent them. Somebody's got their microphone on. Please turn it off. Okay. Thank you. So the more efficient way is just get a bigger drill, and it's just then the difference is enormous because you're going to spend maybe 2 more minutes of drilling every hole, and that is stress on your arms, on your muscles. And if you do 1 or 2 or 5, no problem. But if you have to do 300 of them, then the stress on your muscles and on your body comes in play. Right? So if you get better equipment that you can do more efficient with less effort, yes, please do that. And then there are, instead of putting that insert thing and hitting it with a hammer to expand those flaps here, you're just going to quickly snap on a different attachment on the drill and just go whoop, and that thing is already installed properly. And then you're ready with whatever type of thread to put either bolts or threaded rods in to hang whatever structure you need. Sometimes you can also use something that's called chemical bonds. They are not that uncommon. Look, this is a cross section right here of a cinder block. Depending on the structure, because those here, those drop-in anchors and those threaded rod anchors, they are rated to handle a lot of load. And if you look at some of the specifications on them, you're going to go, oh, this thing can hang so much? All right, a lot of load. However, you can have the strongest anchor in the world, but if the structure here is not enough to handle that load, then you're going to drop everything with the anchor, right? So sometimes, like for example, in the cinder blocks, cinder blocks have little different type of consistency. So if you use the drop-in anchors or anything that expands, sometimes it is not good enough, right? Especially when things that are being moved. I in the past I used to have those the old style TVs that we used to hang on the brackets, and those things were hanging from the cinder block anchors. We had to use chemical bonds because the drop-in anchors, every time somebody touches that TV with that bracket, it would wiggle. It would wiggle. And they would wiggle things out, and it could actually be dangerous. It could be hazardous. It can fall on somebody's head, and things could be disastrous. So we had to use the chemical bonds. That is one of the most strong bonds. And again, it can hold a lot of weight, like seriously, a lot of weight, and becomes part of the structure. Look at some of those, watch some of the videos on the chemical bond. I just want you to know that something like that exists. There are different companies, different brands that are that are selling those, and they all come with instructions, videos, and whatnot. Right? All right. So, okay, it's 11:52 right now. So here's what I'm going to do. Since we have the online thing, if you need to go to another class, please go. I'm just going to continue this until the end, and you can catch the rest of this thing on YouTube if you wish. All right. Oh, yeah, I would strongly recommend. Site work. What else can you expect to find on the site work? Here is the wiring that we talked about, the wiring, how you can mount the wiring. And it's not just to pull a couple wires from one place to another. You can tuck them in somewhere. Now there are some structured ways, as you could tell. All right. Now you're going to have to mount the equipment somewhere. Where do you mount the equipment? Well, there are equipment racks. Look at that. It says 19-inch rack. Remember when we showed you the patch panels, and some of them were wall mounted and some of them were rack mounted? They would be standard width of 19-inch. All right. So here, instead of patch panel, we have something that's called PDU. What's a PDU? A PDU is a power distribution unit, which is basically a glorified way of calling a power bar. Okay? So if you hear PDU, that's what it is. Okay, what do I say here? 19-inch rack is a standardized frame or enclosure for mounting multiple electronic equipment modules. Each module has a front panel that is 19 inches, or here's millimeters wide. 19-inch dimension includes the edges or ears. I will tell you what the rack ears are, that protrude from each side of the equipment, allowing the module to be fastened to the rack frame with screws or bolts. Common uses include computers, servers, telecommunications equipment, networking hardware, audiovisual production gear, and scientific equipment. Now, this is just one example of a rack, equipment rack. Different racks. In our classroom, we have one of those right on the wall. So this is wall-mounted rack. This is a floor rack. And those floor racks could be in the form of a complete enclosed closet, or just a frame that if you look carefully, you're going to see that staring you right in the face, right on the floor in our lab room. Okay. There are certain dimensions here. Now, not going to go into the details of how the holes are spaced on the rack rails, but if you are interested, there you go. These are the dimensions. What happens here is I want you to know some of the terminology. See, here it just shows like 1U, 1U, 1U. Okay. So 1U means 1 unit. What kind of unit? Well, 1 rack unit. Okay. And it just so happens that I have the dimension here. 1 unit is 1.75 inches. 1.75. From here to here. Now, some of the equipment, such as some of those patch panels that we have, are 1U or single U. Some of the patch panels could be double U. Some could be triple or quadruple U's. So this is just to communicate between ourselves and each other to see how big of a rack do you need. And when you get the equipment, it's going to be specified, this is a 1U piece of equipment. So when you're trying to design a system, you're going to have to know how big of a rack you have to get. Is this going to be enough? Or do you need something bigger? The worst thing that that can happen to you is that, oh wow, we got that 600 piece of equipment there, or $300 piece, and it just so happens that the equipment that we have to fit, it's just oversized, maybe half an inch. Oh, Well, that's a that's a bit of a problem. So that's why you have those specifications: 1U, 2Us. Some of those oscilloscopes that we have in our lab room, they are, I think, there are 4Us. Right? Just take a look at those. You know, you're sitting at those desks and at the desks, and this thing is right beside you. Just take a look at that. There will be rack rails, there will be units, numbers, and all that stuff. Eh? Those rack equipment is utilizing something that's called rack screws. There are specific screws with a specific thread that mount on the rack rails. Sometimes the rack rails are going to be threaded, so you could put those rack screws right in there. Right? Sometimes you're going to have those rails unloaded, just like here. Then you're going to have to apply those clips. So there are advantages and disadvantages to both. If the thread is becomes stripped because maybe you overturn it or something like that, you just, you know what, you replace the clip, you replace the rack screw, and you're back in business. If you overdo something on the already loaded, pre-drilled, then, well, it's not as convenient as the unloaded ones. The disadvantage is the other way. You don't have to worry about the clips here. You just bring your screws, put the equipment in, screw it in, there you go. If you forget those clips somewhere at home when you go to the job site, then, it could be in trouble. All right, so this was the last slide here. All right. Now, I just left you. I'm just going to leave you with this last slide because you know what? Here's a couple of rails, here's a couple of screws, rack screws. And where do you get those rack screws? Most of the audiovisual or electrical supply stores, they will carry those rack screws. They're common things to be carried by electrical supplies, or infrastructure data on electrical otherwise suppliers, or if you have some serious music stores as well, they will carry some of those because they use them for the mounting the equipment, music equipment on the racks. And here's the last slide. So I'm just throwing in here couple of, a bunch of screws, couple of rails, and I'm going to leave this thing open-ended because this blues song never ends. Right? I could spend all night talking about those things, but talking is talking, right? With the time that we have given you here in our school, I was trying to give you as much as possible for you to get some good starting point. And from now on, just go out there, get yourself a job somewhere, tell them I taught you. Well, okay. and and just put that knowledge to your work, and earn money with it. All right. Okay. So that is the last slide for this presentation. And look, it's just exactly an hour. It's 12 o'clock, right on the clock. Okay. Thank you guys, and I will see you when I see you. Bye.